All right, atomic theory and structure of the atom. So atomic theory is what you have been working on with your partners, the history, and then we're going to go over the parts of the atom, which really should just be review for you. Okay, this is going to be 5th grade stuff, 8th grade stuff. So this is Unit 2, and I'm going to go over the history very briefly, stuff that you've already been looking at. I'm going to show you the parts of the atom, but I'm not going to sit here and lecture about it because that's why you guys are doing the project. Okay, so next week, when you are actually doing those, when you're doing your presentations, you're going to be taking notes over these scientists, these different scientists. Oops,
Sorry.
thank you. Okay, so history first. We're going to talk about Dalton's atomic theory. So I know there was one group in here with Dalton. Dalton said the following postulates. He said, 1, elements are made up of tiny particles called atoms, and he said that these are indivisible, and indestructible. Dalton said that each element is characterized by the mass, and that atoms of the same element have the same mass. Different elements have different masses. He said that they will combine in whole number ratios, like a 1-to-1, 1-to-2, whatever. You can't combine half an atom. And that they will rearrange in chemical reactions, but the atoms don't change. So my guys, and I don't know if there's any female in that group, who have Dalton, my people who have Dalton, which ones of these are not true, or not, maybe not, that are later changed? Which ones of these are later changed? The indivisible one. And what's the other one that's changed? Not the whole number one, no. The same mass, okay? So you need to know Dalton's four postulates and the 2 that were changed. If number 1 didn't change, then we wouldn't have had the research over J.J. Thomson and Rutherford and Bohr. But those guys came in and changed the first postulate. So that's what you need to know about Dalton. Are there any questions over that? Okay, so let's take a look at the next person. So what happened next was J.J. Thomson came in and said, did this experiment. What he did was he took this cathode ray tube and he shot some negatively charged particles through here, or some atoms. And what he did was he took a magnet, and when he put the positive side to the magnet, he saw that this ray, or these particles, went towards the magnet. And then when he put the negative part of the magnet there, they went away. And so what he said was, in that atom, so you have your atom, and within that atom, you have this, like, positively charged particles, or positive, like, area within that atom. But then he said, within that are some negatively charged particles. So he said the atom was all positive, but inside there were some negative particles, which he called the electrons. My people who have J.J. Thomson, what did he call his model? What was his model later called? Starts with a P. No? The plum pudding model. I like to think of it as chocolate chips cookie. This is a chocolate chip cookie. The cookie part is the positive area. And then each chocolate chip is an electron. Or, yes, is an electron. Okay? So you need to know Dalton, 4 postulates and the 2 that changed. Then you need to know Thomson discovered electrons using the cathode ray tube, and he called it the plum pudding model. Any questions over that? Before I go to the next slide. All right. This, you don't have to write this down. This is just extra info. This talks about how Robert Millikan came in and used the electron, and he found out the mass, what the mass of an electron actually is. All right. Next, we have Rutherford. Rutherford, you need to know Rutherford did the gold foil experiment. So what he did is he had this gold leaf, okay, and he saw that as he was hitting alpha particles, which are positive, towards this gold leaf, what happens was that most of them went straight through. They're going straight through and they're not hitting anything. They're just hitting right behind the gold foil. But every once in a while, he would see something deflect off, okay? And so what he said was that, yes, we have an atom, but the atom has a center in it, and this center is positively charged. So now not the whole cookie is positive, just this center. And that's what those alpha rays are doing. The alpha rays are positive. The alpha ray comes in, it's usually going straight through here, but every once in a while it hits this positive center, and when a positive hits a positive, it shoots off in another direction. And then what we have is our electrons out here. So now we have our chocolate chip cookie, but instead of the cookie being our positive, we have a big Hershey's Kiss that is our positive. And this is just empty space. The cookie is just empty space. Okay, so he said we have a dense, positively charged nucleus. So you need to know that Rutherford did the gold foil experiment, said we have a positively charged nucleus, and that contains the protons and the neutrons. Okay, this is again his what he did. I'm not going to go over that. That's for you to go back to. But I do want you to realize here that these things have mass. All right? The mass of a proton and a neutron is 1.67 times 10 to the minus 24th. It's really, really tiny. We just go ahead and just call it 1 unit. So 1 proton is 1 unit. If you have 2 protons, then 1 plus 1 is 2. Okay? A neutron is 1 unit. And then electron is times 10 to the 28th, negative 28th. So it's very, very, very small. So here, atom, and here is your proton. So the mass of the atom is in the nucleus, and the nucleus contains the proton, which is positive, P, proton, positive charge, plus the neutrons. Does anybody remember what the charge of a neutron is? Neutral. So I'm going to put a 0 there. Positive, proton positive plus the neutrons, and that equals the mass of my atom. So the mass of my atom is in the nucleus. The outside of the atom, what's outside the atom or the nucleus? The electrons, and that is going to make up most of the volume and the electron cloud. So the volume is from the electron cloud, E negative. Okay, so nucleus has your protons and your neutrons, and this is where all your mass is. And then out here is your electrons cloud, and that makes up your volume of your atom. So your atom is very big, especially compared to the size of the protons and the neutrons. But it's because of the electron cloud. Any questions over that? So some important terms that you need to remember. Oh, wait, not this. Here is, again, a visual. So I need you to remember that the number of protons is equal to the number of electrons in a neutral atom. Keyword, neutral atom. Every atom on the periodic table, every element in the periodic table is neutral. The way you see it up there is neutral. And that means the number of protons equals to the number of electrons. So electrons is the volume, and this is the mass. Everybody good with that? Again, if you don't like writing, you can always go and put them on your iPad. Put the notes on your iPad and follow along and make notes in there. Okay, so now, you should remember this from middle school. Any periodic table, either at the top or top center or to the left or the right, you have a whole number, and that is the atomic number. And the atomic number represents what? Can somebody tell me? Number of protons. So number 6 is carbon, which means it has how many protons? 6. Then you have the symbol on your reference chart that you use during your test or whatever. It says C, and then underneath it, it says carbon. Okay? That has it there for you. When you get to AP Chem, we take that away. And then you have this number, this decimal number on this periodic table or on any periodic table, and that is the atomic mass. Okay? This is a weighted mass, like your grade is weighted or your GPA is weighted. Okay, this is weighted, so certain percentage makes up this mass. We are going 2 decimal places. So when we start working problems, don't say, hey, how many places are we going on the atomic mass? We go 2 decimal places. If I tell you that carbon has a mass and I don't tell you what its mass is, you're going to look at the periodic table and you're going to find the atomic weight and you're going to round it to the nearest whole number, which in this case would be 12. You cannot have 0.011 of a proton or a neutron. We're going to round it to the nearest whole number. Everybody good on how to read this? Yes.
So since the atomic number is 6 and that's how many protons, is that how many electrons there are too?
Yes, good question. So since the atomic number is 6, that's how many protons it has. That is how many electrons it has in this case too. No. All right. Now my important words. Oh yes.
You said that the number of protons equals the number of electrons in a neutral atom.
Yes.
How do we know if an atom is neutral?
How do I know an atom's neutral? If it's up there in the periodic table and you just go and grab it from the periodic table, it's neutral. Now, if it says something, and I'm going to get there here in a minute, and I'll tell you. All right, the atomic number is the number of protons. It defines the atom. If I tell you your atomic number is 6, and we're going to add a proton in there, what's your atomic number now? 7. And you are no longer carbon, you are now nitrogen. So if you change the number of protons, you change the atom. You're no longer that element. So this is the protons, number of protons. The mass number is going to be my protons plus my neutrons. So if I tell you you have 32 protons, then look up there and tell me what's the mass number if you have 32 protons. 73. Oops. So if you have 32 protons, then your mass number, and that means how many neutrons do you have? So 73 minus 32 gives me 41. 41 neutrons. All right. An isotope is atoms of the same element that have different number of neutrons. So we can have number 32, but 32 this time can have a mass of 78. If atom 32 has a mass of 78, now how many neutrons does he have? 46 neutrons. So, mass number changes. When your mass number changes, what happens? What changes in your atom? The number of neutrons. Okay? Your number of protons in the atom cannot change, because if it does, it changes the atom. And then an ion. It is one that has gained or lost electrons, one or more electrons. So, sodium, if I just said sodium, and nothing is there, just says this, that means it is neutral. That means protons equals neutrons. Or, sorry, protons equal electrons. Now, if I say Na plus 1, now that is its charge. Okay? This means sodium has a plus 1 charge, which means it lost an electron. So it lost an electron. And I'm going to go over how to figure that out here in a minute. It's counterintuitive. Pluses mean you lost. Yes. So if I'm oxygen, I'm neutral. If I'm oxygen with a -2, now I am charged. I have a -2 charge, and that means I gained 2 electrons. Because electrons are negative. Yes. Huh? It's the opposite. It's counterintuitive. And I'll show you how to do the math to it. But if I'm 0, then I'm equal at this. This means protons equal electrons. Over here, it means protons are less than electrons. Because I have more electrons here. Okay? So let's do the math. So looking at the periodic table, so I am going to give you an element. Let's look at sulfur. Sulfur is S. So write down its atomic number. So what's sulfur's atomic number? 16. And what's its mass number? 32. Huh? 32 point what? 32.066. All right, so how many protons does it have? It has 16. How many neutrons does it have? Well, we have 32 minus 16 gives me 16. This is a neutral sulfur atom. So its atomic, to find the number of electrons, it's going to be its atomic number minus its charge, which is 0. So it is 16. So it has 16 protons, 16 neutrons, and 16 electrons. But what changes if I tell you you have sulfur minus 2? So now we have the atomic number. So we still have 16 protons. We have 16 neutrons. But now our electrons is going to be 16 minus a minus 2, which tells me it is 18 electrons. So your atomic number minus your charge tells you how many electrons you have. So when you subtract a negative, it becomes positive.
So if there's no charge, the electron is still the same.
Yes. And then we're going to do 2 examples, and then I'm done. Everybody good? All right. Now, if I tell you something like this, let's say I am going to give you barium 135. 135 is the mass number. So I've actually told you its mass number rather than you looking at the periodic table. So tell me, how many protons does it have? Barium is Ba. 56. How many neutrons does it have? 135 minus 56 is what? Something 9. 49? 79? 79. And how many electrons does it have? 56. All right, so now I have sodium. So I'm going to do sodium 25 with a plus 1 charge. So how many protons does sodium have? Sodium is Na. Is 11. How many neutrons does it have? 14. How many electrons does it have? 10. Are there any questions over that?